electrical power and energy. Let's go. This is the introduction. I want you to know something. Electrical power, electrical energy, let me represent it with my W, is Q times V. Meaning is quantity of charge times voltage. I want you to know something. Electrical energy is measured in joules. And my quantity of charge, which is Q, is measured in coulombs. This is what? Like I said, is QV. The voltage is measured in what? In volts. Now, let's go to proving the formula proper. But I will call this equation 1. But the quantity of charge is current times time. Please, as I'm writing this thing, be writing it down on your jotter. I already said that Q is the quantity of charge measured in coulombs. I is the current, and current is measured in amperes. And T is the time measured in what? In seconds. And this is equation 2. Now look at what I want to do. I want to put equation 2 into 1. This is what I want to do. So whenever I see, now I'm going to put 2 into 1. So Q is equals to, W is equals to Q times V. So whenever I see Q, I'll replace it with IT. And this will give me what? I times T times V. So therefore, electrical energy is IVT. And this is my what? Equation 3. Now from Ohm's law, we know that V is equals to current times R. V is equals to IR. And let me call this my equation 4. Now look at what I want to do. I will put 4 into 3. I will put equation 4 into 3. So wherever I see V in equation 3, I will replace it and put what? I times what? R. So this will give me I times, rather than putting V, I will replace it with what? I times R times what? T. So remember, we now have 2 currents. So this will give me what? I square RT. And this is equation what? 5. So electrical energy is I square RT. This is equation 5. Equation 6. From the same Ohm's law, remember I said V is equal to IR from Ohm's law. So I can decide to make I subject of the formula, and it's going to be what? V all over R. And let me call this my equation 6. So what I'm going to do right now, I'm going to put equation 6 into equation 3. So remember, equation 3 is IVT. So what I'm going to do right now is, wherever I see I'll replace it and put V all over R. So this will give me V all over R times V times what? T. And this will give me what? V square all over what? RT. Are you seeing it? Good. So now this will lead me to, for you to know that electrical energy have the following formulas. We said from following equation, electrical energy is QV. It's also equals to what? IVT. It's also equals to what? I square RT. Another equation or formula I proved is that electrical energy is what? V square all over RT. That was another formula I proved. So the above 4 formulas is for solving what? Electrical energy. We are going to start using it to solve example in the next video. Now remember, the topic is electrical power and what? And energy. Now we have successfully proved the formula using calculating any electrical energy related what? Problems. Now I'm going to continue to drive the other equation for what? For power. Now I want you to know something. The definition of power, why physics is so easy. Is all you need to know is the formula, the mathematical representation of it, the SI unit and what it stands for, and your answer will start flowing naturally. Remember, if I ask you to define power, and you tell me that power is energy all over time, and you tell me the SI unit, I will give you your full mark, and whoever that is marking you will give you your full mark. So remember, power is energy all over time. The SI unit of power is watt, can also be kilowatt, can also be in horsepower. Now, I want you to know something. Remember, I proved before that energy, remember energy, electrical energy all over time. But I have already proved at the beginning of the video that electrical energy is what? QV. This is my equation 1. Remember, I'm talking about power now. We are in electrical power. So electrical energy is Q times what? V. And this is equation 2. So basically what I want to do is wherever I see, so, and that will be P is equal to Q V all over T. And that is one formula for calculating power. Now, remember we proved, look at it here, that electrical energy is IVT. We already proved it. Remember we said electrical energy is IVT. So, let me call this equation 4. I'm going to put 4 into 1. And that will give me that my power is IVT all over T. This will cancel this, and that will give me what? IV. Power is current times voltage. This is equation 5. Remember also, electrical energy is I square RT. Let me call this equation 6. I'm going to put 6 into 1 again. So power is going to be I square RT all over T. This will cancel this, and that is going to give me what? I square R, and that is my equation 7. Are you seeing this? So since power is electrical energy all over time, you can see all this formula I proved, I am just cancelling out T in it. So please remember also that the electrical energy is also V square all over RT, right? And if I call this my equation 8, and I put 8 into 1, power is now going to be equal to V square all over R times T divided by T. This will cancel this, and therefore power will now be V square all over R, and that is equation 9. Now, the same thing we just did here, the same thing I did here when I was defining electrical energy, I also want you to know that power is now equals to, for all these things we just proved, power is energy all over time, which is QV all over T, which is equals to IV, which is equals to I square R, which is also equals to what? V square all over R. All these are definition of power, which I'm going to be used for my calculations. And all these are definition of what? Electrical energy, which we are going to use in solving various calculations. It's very much expected you know how to prove all these formulas. In my next video, is going to be basically mainly on calculations on all these various quantities. Now, time for us to apply our formula to use. The first example is calculate the resistance of a filament of a lamp rated 240 volts, 40 watts. And when you see watts as the SI unit and this, you already know they're talking about power. So this is our solution. From the formula I proved, You already know that power is electrical energy all over time. It's also equals to QVT all over time. It's also equals to what? IV. It's also equals to I square R. It's also equal to V square all over R. Now, you have voltage, which is 240 volts. And then you have power, which is 40 volts. In this formula, which one do you think is going to work out? Yes, of course. The one is going to work out is what? They want us to calculate the resistance. So it's going to have to be this. Because we have two knowns and one unknown. So power is what? V square all over R. You can't use this, you can't use this. Why? Because they do not give you current. You can also use this because you do not have what? Quantity of charge. You don't have quantity of charge. So this is our best formula to use. And you can see the set electrical resistance. So R is what you need to find. So you see your R is equals to what? Voltage square all over power. And your voltage is 240 all in square divided by power, which is what? 40. You punch it in your calculator, you should get an answer of 1,400 ohms. Remember, the SI unit of resistance is what? Ohms. The SI unit of current is ampere. The SI unit of energy, we already said, is joules. Please note that very well. We are in example number 2. You can see the maximum power by a 100 ohms resistor in a circuit is this. Calculate the voltage. Now, this is our solution. You have a resistance of 100 ohms for the equation. Your power is what? 4 watts. They want you to calculate the voltage. You can also see from here what formula do you think is going to work out. It's still this our formula because current is not what? Given. So you have that power is equals to V square all over R. So all I need to do right now is make R subject of the what? Of the formula. Make R subject of the formula from the above. Okay, make V subject of the formula. We have P is equals to V square all over R. And they ask us to calculate V. So V square is what? P times R. But what we are asked to calculate is V, not V square. So V is equals to what? Square root of P times R. Now you have 4 times 100 square. So your V is this time, this will give you 400. And root of 400 is what? 20. Never forget the SI unit in physics. This is what? Volts. And then your answer is what? 20 volts. In the next other example, the next video I'm going to release on the electrical energy and power, more calculations will be released. Thank you very much.